Welcome back, guys. We are discussing the miscellaneous exercise of chapter number 9, and in this video we are going to discuss example number 13 and onwards. So question number 13 is if a equal to bx a plus bx upon a minus bx is equal to b plus cx upon b minus cx is equal to c plus dx upon c minus dx, then show that a b c d four quantities are in gp, right, where x is not equal to 0. So we have this expression a plus bx upon a minus bx, b plus cx upon b minus cx, c plus dx upon c minus dx. So applying ratio and proportional, I'll get this kind of term like 2a upon 2bx, 2b upon 2cx, 2c upon 2dx. Cancelling 2 from numerator and denominator, I'll get a upon bx, b upon cx, and c upon dx. Let us say equal to k. Now from here you can write a is equal to bkx into k means bkx, b upon cx equal to k means b equal to cxk, and c equal to dkx. Now from here I can write b equal to a upon kx, c equal to b upon kx, but b has the value a upon kx, so this will be a upon kx into kx, so a upon kx whole square. Similarly from here I can write d is equal to d equal to c upon kx, but c has the value a upon kx whole square, so a upon kx whole square into kx, so it will be a upon kx cube. Now taking 1 upon kx equal to r, this will be b will be a into r, c will be, this can be r square, so c will be ar square, and similarly from here d will be ar cube. Now you can observe that the ar square and ar cube, they have the common ratio r, so we can say that a b c d are in gp. Moving on to the next question, question number 15. The pth, qth and rth term of an AP are a, b, c respectively, and we have to show that this expression equal to 0. Let us say that first term on common difference of an AP is capital A and small b respectively. Given that AP means pth term is A, qth term means AQ is equal to B, and rth term, that is AR, is equal to C. Now I have taken first term is capital and common ratio small d, then this will be AP equal to, I can write A plus P minus 1 into D is equal to A. For this I can write A plus Q minus 1 into D is equal to B, and AR, A plus N R minus 1 into D is equal to C. Now to prove this, let us start with right hand side. Q minus R into A, R minus P into B, plus P minus Q into C. Just substitute the value of A, B and C in this expression and perform some calculation, you will get your answer as 0, right? Moving on to the next question, that is question number 17. If A, B, C, D, 4 terms A, B, C, D are in GP, prove that these 3 terms are in GP, means A raised to n plus B raised to n plus B raised to n C raised to n and C raised to n plus D raised to r in GP. We have A, B, C, D are in GP. Let us assume that the common ratio is R. Then second term B is equal to AR. As first term is A, then B equal to AR, C equal to AR square, and D is equal to AR cube. Right. Now we know that if 3 terms are in GP, suppose A, B, C are in GP, we can write that A into C is equal to B square. Means multiplication of first and third term is equal to the square of the middle term. A into C is equal to B square. To prove these are in GP, I'll multiply first term and this term, means A raised to n plus B raised to n and C raised to n into D plus D raised to n. A raised to n as it is, B raised to n has the value AR, so A raised to n, R raised to n, and similarly putting the values of C and D over here. Now apply some calculations and take out some common, like A raised to 2n and R raised to 2n is common, and do some calculation. You will get B raised to n plus C raised to n whole square, means middle term square, according to this definition. So we can say that these 3 terms are in GP, hence proved. Let's move on to the next question, question number 19. The ratio of AM and GM, arithmetic mean and geometric mean, of two positive numbers A and B is m raised to n, so that A upon B, A raised to B is this. Now this is not arithmetic progression and geometric progression, it is arithmetic mean and geometric mean of two numbers A and B. Suppose two numbers A and B are this, then arithmetic mean is denoted by capital A, that is A plus B by 2. And similarly, geometric mean is given by under root of AB, square root of AB. Now we have what we have. The given thing is ratio of AM and GM, means ratio of A upon G is m raised to n, is m upon n. Now substituting the value of A, that is A plus B by 2, and G, that is root of AB, is equal to m by n. Using ratio and proportion, A plus B minus denominator and A plus B plus denominator, and denominator has A plus B minus denominator, means square 2 into square root of AB. This will be m plus n upon m minus n. Now you can see that it is the term root A plus root B whole square, and denominator has root A minus root B whole square. So left hand side will be this and right hand side will be same, m plus n upon m minus n. Now let us take square root on both sides. This is just calculation. Square root of both sides. So it will be square root of A plus square root of B upon square root of A minus square root of B. And here it will be square root of m plus n upon square root of m minus n. Now again doing the same thing, square root of A plus square root of B plus denominator, and square root of A plus square root of B minus denominator, that is square root of A minus square root of B. Root m plus n plus denominator, root m plus n minus denominator. Open the bracket and you will get 2 root A upon 2 root B. This will be same. So taking square on both sides. So square root of 2 to cancel, and now taking square on both sides. So square root cancel. So it will be A by B. A square, this of square, this whole square will be this square plus 2 times this term and this term. So m plus n plus m minus n plus 2 times of this into this. Same way the denominator. Apply some calculation, you will get your answer. Moving on to the next question. Question number 21 has two questions. I am going to solve the first one only. Find the sum of n terms of the series 5 plus 55 plus 555 plus and so on. We need to find the summation of n terms. So I am starting with 5 plus 55 plus 555 and so on. There are n terms. I am taking out 5 common. It will be 1 plus 1, 11 plus 111 and so on up to n times. Multiplying and divided by 9. So 5 by 9, and now multiplying this term as with 9. So it will be 9, it will be 99, 999 and so on up to n times. This 9, for this 9 I can write 10 minus 1. For this 99 I can write 100 minus 1. For this 999 I can write 1000 minus 1 and so on up to n times. Now 5 by 9 doesn't matter, it will be as it is. Now there are n terms. You can see there are n brackets. I am taking the first term in another side. 10 plus 100 plus 1000 and so on. There are n terms. Minus 1 minus 1 minus 1 minus 1 n times. But minus is common, so it will be 1 plus 1 plus 1 up to n times. Now you can see that this is a geometric series with ratio r equal to 10. So a r raised to n minus 1 upon r minus 1 minus this 1 r total n times. So it will be n. If 1 is 5 times, it is 5. Now it is 10 n times, so it is n. So 10 raised to n minus 1 upon 10 minus 1 is 9 and minus n. Just multiply 5 by 9 inside the bracket and you will get your answer. So that's it for this video. Thank you and Jai Hind.